All right, I'm going to argue this is probably the hardest question that you got going on this worksheet. It's tricky. And we get the cyclist, right? So we got cyclist number 1. Okay, he's fixing a plat. Right? And then the cyclist number 2, he goes by, let's see if I can draw a better cyclist. I'm a cyclist. He is moving at a particular speed of 3.5 meters per second. But this cat waits for 2 seconds, and then he has an acceleration, that's different, right, of 2.4 meters per second squared. But there is a t 2-second delay. So it's not t is 2 seconds. This is tricky. So what you want to do is you want to write the equations. Again, the equations down here, xf, xi, right, of both cats. So let's call it st for the stopped cat, and s for the constant speed cat, right? And you're going to write this out, right? xo plus vot, original, you can say vi, sorry, I mixed my metaphors here, 1/2 at squared. Now, the constant guy is going to be easy. His original position is at, we're going to say original position is here. This is the 0 position, plus VOT plus 1/2 AT squared. If he has constant velocity, the acceleration term drops out. His original position, we'll assume, is when he just passes his friend. So this is just going to be the VO. We know V is 3. You're going to write the equation. Make a note. We're not trying to do anything but write the equation. Okay? And then we're going to set them equal to each other. That's what we're going to do. And solve for T. But the trick on the T is that when you put the T in here, okay, this is the hard part. All right, you're not going to say T, you're going to say parentheses T minus 2. Because he's got a delay and that becomes squared. So this will be 1/2 times his acceleration, which was 2.4. And then you're going to have a T minus 2 squared. Because what you're trying to do is when they pass each other, that's when x equals x. Okay, so you're going to set these two equations equal to each other. This is the trick, is adding the T minus 2. It becomes kind of a pretty nasty quadratic. I have lots of mathy stuff sitting in front of me. So that's the gist of how you solve this. And when you try and solve the speed when he catches up, all right, you're going to use the same equation. But in this case, you're going to know what x is. You're going to plug in the answer you get from when you set these equal to each other. All right, you're going to solve for the time. And once you know the time, say, the time is some number, whatever it is, you can replug that into this equation and then solve for x, and that's how you get b. It's a tough question mathematically because it's a lot of crazy quadratic-y stuff. And there's, with quadratics, there'll be 2 answers. Only one will make logical sense.